once I pull it all up.
You putting it in the chat window?
Yeah, it's almost, I'm pulling all the, connecting to the websites and everything.
I just didn't know if you were going to put it in the chat window or send me an email to the link.
That'll be the chat window.
Okay. You're one of the few people that does it that way. Most people will send me a picture of the material and they'll send it to my email.
Yeah.
Chat window actually is a more direct way to do it. So.
I agree. There we are.
Okay.
We finished the first page last time.
Okay.
So we've got, and I finished the other two, so we only have like the last 2 pages really.
Tell me what question you want to start on.
It keeps going. I was like 19, I think.
What's the correlation coefficient mean?
Isn't that isn't that where one of the points lies?
It's a measurement of how well the data points fit the line.
Oh, okay.
In other words, let me draw an example.
Alright.
If I had a bunch of data points like this, I could draw a line through that.
Yeah.
But if I had a bunch of data points like this, this is a much higher R than this is.
Yeah.
In other words, all of the points are almost in a straight line already. Whereas over here, there's more scatter.
Yeah.
So the correlation coefficient is a measurement of scatter. And it's not always just for straight lines. In other words, if I had a parabola that was modeled by these points, that would be a pretty good correlation coefficient as long as I used a quadratic to model it.
Yeah.
But if I had a bunch of points kind of like this, I could still model it with a quadratic, but it wouldn't go through all the points. I'd be approximating. There's a lot of distance between the point and the curve. The more distance there is, the lower correlation coefficient you're going to have. The maximum correlation coefficient is 1. And that means all of the points either line up in a straight line or they line up in a parabola. It depends on what you're using. In other words, if I've got points in a straight line, I'm going to use a linear regression.
Okay.
If I have points that look like they might be in a parabola, then I'm going to use a quadratic progression. If I have points that look like they might be logarithmic, I'm going to use a logarithmic progression. Or regression. All of them depend on the equation as to which one makes the most sense. Whether you use linear, quadratic, logarithmic, cubic, there's all kinds of regressions. Now, let's look at the next question here. What would be the residual for point A? When they talk about the residuals, they're talking about the perpendicular distance to the line.
Oh.
I think.
Probably.
Not 100% sure, but I can't imagine what else it would be.
Yeah.
What's the residual for B?
Would it be for A?
For B.
0.
for C?
Um,
Whatever that distance is there.
yeah, 4?
I don't know. It's a slanted distance, so I can't measure it based on the grid system.
Yeah.
In other words, I would have to take the distance between that point and that point. Use my distance formula.
Yeah.
All right. Let's go down. Wait. Do the best I can. I can't guarantee anything here. I think I know this. Whenever you have a table where in this case, there's actually 8 possibilities, right? You can be a male who does no sports, or does 1 sport, or does 2 sports, or 3 sports. That's 4 possibilities. And you can be a female who does those same 4 choices. So that's 4 more possibilities. So we've got lots of combinations. The one thing we know is that we have 100 students. 50 males, 50 females.
Yeah.
We have 26 students playing no sports, 24 students playing 1 sport, 29 playing 2, 21 playing 3. Those have to add up to 100 also.
Yeah.
All right. Now, when they talk about the joint relative frequency, what they really want to know is what is the percentage of males playing no sports out of everybody? Well, it's 9 divided by 100.
Yeah.
That's how you get 0.09. And in fact, I'm a little puzzled. Okay. In other words, this table comes from this table, taking every cell and dividing it by 100. And you're dividing it by 100 because that number is 100. You don't always divide it by 100. You always divide it by whatever that number is.
Yeah.
And that's how you get the relative frequency in any given cell.
Yeah.
Okay, so they got the second table from the first table. Now, what's the joint relative frequency that somebody is a female and plays 3 sports? Well, that's that thing right there.
Yeah, 0.12.
That's the answer, 0.12.
Yeah.
What's the probability that somebody plays 1 sport and is a male?
15%.
You got it. So once they put it into a relative frequency table, then it's pretty easy to answer any questions they have.
Yeah.
And putting it into a relative frequency table isn't really hard. You just take whatever number you find and divide it by that. If that were 110, then you'd divide that number by 110, and whatever percentage you get, that's what would go there.
Yeah.
Okay. I think you get that. #21. 3 primary methods of solving a system of equations are graphing, substitution, and elimination.
Yeah.
How does graphing solve it?
Useful then.
Graphing solves it because that's a straight line and that's a straight line. And wherever they intersect is the solution. That would be the solution.
Yeah.
Both for the x and the y coordinates. So graphing is a tremendously easy way to solve it, but not terribly accurate because, well, first of all, you have to graph each one, and then you have to read where the intersection point is. So graphing is not a very good solution. But it's one of the three methods they've taught you.
Yeah.
Now, the other method is substitution. How do I solve this by substitution?
You substitute. Or something 21 for substitution.
The problems that you're going to use substitution to solve are one where one of the equations is fully defined in terms of one variable, like this. X is fully defined. It's not over here.
Yeah.
But I only need one equation where one variable is fully defined, and then substitution makes a lot of sense. I'm going to substitute this value of x minus y plus 4 wherever I come across x in the first equation. So instead of x, I'm going to write minus y plus 4 minus 5y equals minus 8. Now, that is an equation that only has one variable. I can always solve equations that only have one variable. What gives me problems is when I have two variables and only one equation. You can't solve those. But if you have two equations and two variables, you can, by either substitution or elimination, you can get rid of one of the variables and turn it into one equation and one variable. Now, tell me how to solve that. What's the next line?
Next is minus 2y plus 8 minus 5y equals minus 2.
Okay, this is a linear equation. So you always just want to get all your variables on one side, everything else on the other.
Yeah.
So what's the next line?
Next line is minus 6y.
7y.
7y equals minus 16.
What's y equal to? 16 over 7. The minus signs disappear, but you still have to divide both sides by minus 7.
Yeah.
So that's y. And once you solve for y, you still have to solve for x. In other words, you've only solved for one variable at this point. But it's pretty easy to solve for x because we know x is equal to minus y, so minus 16/7 plus 4. Well, that is 2 2/7. So we've got 1 5/7 is our answer for x. So x is equal to that, y is equal to that.
All right.
And that's that. Now, let's look at 22.
All right.
How do we know if that's a solution or not?
We have to plug it in.
Okay, so tell me what to write.
All right. We have minus 21.
Well, no, plug it in first. I really am not fond of doing two steps at once.
All right. 7 parentheses negative 3 minus 3 parentheses 6 is less than or equal to minus 4.
Yeah, and that's irregardless of your math skill. I could be talking to Einstein and I tell him to do it this way.
Yeah.
Okay? Because now you just have to simplify, and it's much harder to make mistakes. I've only got two things I got to do. I got to multiply 7 times minus 3, and I got to multiply 3 times 6.
Yeah.
So what do we got?
We have got
Step by step. What's 7 times minus 3?
Minus 21.
Okay. What's that?
Minus 18.
All right. Now the question is that less than minus 40? Well, what's minus 21 minus 18?
That's minus 41. Not minus 39, sorry.
Is that less than minus 40?
Yes.
No, it is not. If I look at a number line, there's 0. There's minus 40. There's minus 39. It's to the right of minus 40.
Oh, yeah.
So for something to be less than another number, it's got to be to the left of it.
Yeah, true.
In other words, just because 39 is less than 40 doesn't make minus 39 less than minus 40.
Yeah.
All right. The next one.
That's 124 or 23.
23. What's the best first step? I got two denominators here.
Oh, we need to get common denominators.
Not necessarily.
We don't? Alright.
No, I don't have this. I mean, I could have that if I wanted, but I don't have that. Not yet.
Yeah.
And right now, I just got one denominator or one fraction on one side of the equation, another fraction on the other. Think cross multiply. In other words, 4 times x minus 1, I'm multiplying both sides by x minus 1 to get rid of it, equals 8 times 6. I'm multiplying both sides by 6 to get rid of it.
Yeah.
Now we have a really simple thing. 4x minus 4 equals 48. 4x equals 52. X equals 13. So when you have equations that look difficult to solve, always be thinking, let's get rid of denominators and parentheses. Those are your two primary things. Denominators, parentheses, and exponents. You always want to rid yourself of those to make an equation simpler. And most people have quite a bit of problem when there's any kind of a fraction in an equation. If I gave you this problem, it would be tough, not because it's tough, but because we got all kinds of fractions in there.
Yeah.
Well, the first thing I'm going to do is multiply everything by 3. So I get 3 minus 1 equals 2x plus 30. Now it's simple. So always be thinking, get rid of denominators when you're doing equations that are difficult looking like that.
Alright.
Provide an example of a pair of complementary angles. Give me an example of two angles that are complementary.
Complementary.
Sorry, what?
Maybe, couldn't that be like...
Let's start with the easier ones. Supplementary. Give me two angles that are supplementary.
Supplementary add up to 180.
So give me two angles that add up to 180.
90.
Complementary is half of that. Complementary angles add up to 90.
Okay.
So give me two angles that add up to 90.
45, 45.
Give me two other ones.
Two angles that add up to 90.
They have to add up to 90 for them to be complementary.
50 and 35. No, wait.
Doesn't add up to 90. It adds up to 85.
Yeah. 50 and 40.
Okay. Just want to make sure you knew that they didn't have to be equal.
Yeah.
They just have to add up to either 90 or 180. And they're complementary or supplementary. Okay. Find the area and the perimeter of that polynomial that we're looking at. Well, the perimeter, what's the perimeter?
The perimeter is, oh, that's a lot. Hold on.
Give me the expression.
We have 3x plus 5x.
All I heard was 3x.
16x.
Hold on. Stop. Where are you getting 16x from?
By adding all the x's together.
Nope. Let's not do it. Let's write an equation first. Always do these things one step at a time. People get in problems because they try to do multiple steps at a time. You don't need to be adding the x's yet. Just write out a statement that is true. 3x plus what?
3x plus 6x.
No, 3x plus 6. In other words, I'm adding that to that to what else?
3x plus 6.
Plus what?
Plus 2x plus 1.
Keep going.
Plus 6x plus 6. Plus x plus 2.
That looks like it would be the perimeter, but it's not. What did we miss? We missed this distance right here.
Yeah.
But we got every other distance. We got this distance, we got this distance, we got that, we got that, and we got that. So the only thing we have to add is that. What is that?
What would that be?
Well, what is it? We know what this distance is, and we know what that distance is. We can figure out that distance. What is it?
2x plus 1 minus x minus 2.
And use parentheses. If you do not use parentheses, you'll get the wrong answer.
Yeah.
So what's that result?
That result is 2x plus 1 minus x minus 2.
Simplify that. Remove the parentheses. What do you get? Remove the parentheses and combine like terms. That's always what you do in algebra, is remove parentheses and combine like terms.
You get 3x minus 1.
No, 2x minus x is x.
Oh, yeah.
Plus 1 minus a minus 2 is 3.
Yes.
So that's the missing dimension. So if I add x plus 3 to everything else we had, that's the perimeter.
Yeah.
Now is all I got to do is combine like terms. Now you can do the step that you wanted to do right off the get-go. But you can hopefully see why that's not a good thing to do. Because I end up with 1, 2, 3, 4, 5, 6 terms. I don't want to be juggling that in my head.
Yeah.
I want to write them out and then do the math. Then do the juggling.
Yeah.
How many x's do we have? That was not x minus 2. That was x plus 2.
Yeah.
That changes a lot. In other words, I'm going to get the wrong answer if I used x minus 2, which I did. It's because my writing was over top of it. I couldn't see it. So this little distance right here is 2x plus 1 minus x plus 2, which doesn't give you x plus 3. It gives you x minus 1. So that third dimension, or that third side that I've circled, is x minus 1. You cannot make a mistake of any kind when you're doing these. If I make a mistake on a sign, I'm getting the wrong answer. So you absolutely have to be perfect. And there's a lot of steps here. There's 6 or 7 steps. Now, combine everything. How many x's do we have?
Combine all each. There's 6 and 8. There's 15.
We have 16. We have 3 plus 3 plus 2 plus 6. That's 14. Plus 1 plus 1. That's 16. How many numbers do we have?
We have 6, 7, 8, 15.
Don't forget this minus 1.
No, 14.
There's your perimeter. Now, let's look at the area. The area actually is a much easier problem, even though it doesn't look like it. It is. And here's the reason. If I look at this area as being the outside rectangle minus this little inside rectangle, I get all of this, right?
Yeah.
I get the area of the polygon. That's what they want, the area of the polynomial.
Yeah.
I don't know why they call it a polynomial. It's not a they didn't mean to call it a polynomial. They meant polygon. Okay? So that's the way to go about doing this problem. What is the area of the big rectangle? In other words, this rectangle here.
The area of the whole?
Yeah. Just give me an expression. Don't multiply it out. Just give me the expression.
6x plus 6 times 2x plus 1.
Yeah, and make sure you always use parentheses. If you omit the parentheses, you're getting the wrong answer. Okay?
Yeah.
Now, what's the area of that little tiny spot there? If I can subtract it, then I'll be good.
It's 3x.
Okay, we know it's 3x. And if you remember when I did the perimeter, this came out to be x minus 1. That distance. So it's 3x times x minus 1 in parentheses. That's going to be the area of that shaded region. And that's relatively easy to do. In other words, you end up with a quadratic expression because that always gives you an x squared. That gives you an x squared. So you got to multiply these two together, multiply those two together, subtract them, combine like terms, like numbers. That'll be your answer. Now, they're a little bit misleading here, and when they say find the area and the perimeter, kind of makes you think that you can come up with a number. But you can't. They didn't give us any numbers. All they did is give us x's. So our answers have to be in terms of x. Clearly, I could make x 1, and I would have one dimension, but I can make x anything. I can make it 10. So this polynomial does not, or this polygon is not a specific polygon. It is a function of x, which means its perimeter is going to be a function of x, and its area is going to be a function of x.
Yeah.
even though they don't tell you that when they ask you the question, it'd be easy to spend a lot of time trying to come up with a number. Can't do it. What's the equation for 26? What's volume of a rectangular box equal to?
The volume of, well, you get base times the times height.
Okay? Fill in everything here, and then we'll multiply it out. Always fill it in first.
Equals x. So we have.
Hold on. What's the first term?
3x minus 1.
Okay. Where are you getting, hold on. Where are you getting 3x minus 1?
Yeah.
Where are you getting that?
I'm just combining 2x minus 3 and x plus 3.
Don't do that. Again, you're getting ahead of yourself. And it's not correct to do that. Not only are you getting ahead of yourself, but you're making a mistake when you do it. So don't do that. Write out the expression and then simplify. What's the base? What are the three dimensions? Give me the three dimensions.
The base is x plus 2.
What's the next dimension?
2x minus 3.
And the third dimension?
3x minus 3.
Now, you see that now I got to multiply these three terms together, whereas you were adding those. You're not adding them. So that's an excellent reason why you don't do two steps in one. Is always lay out the equation and then solve. And this isn't that trivial to do. You have to FOIL this with one of the other terms, and then you're going to have a trinomial multiplied by a binomial. So multiply these two terms. What do you get?
Multiplying the first two?
As good a place as any to start. Right? In other words, I could multiply the second and the third, but let's work from left to right. What do you get?
I would get 2x squared.
FOIL.
Is that minus 6?
Hold on. You're just doing these two terms. FOIL them. You know what FOIL means?
I've heard it, but I don't remember.
Well, they may not, they don't teach it everywhere anymore. It means when you're multiplying a binomial by a binomial, you're doing the first term times the first term of the second. In other words, here, let me draw it out. What you're doing is this term times that. Then you're doing that term times that. That's the O of FOIL. That's the outside terms. Then you're doing the inside terms. That's the I of FOIL. And then you're doing the last two terms. That's the L of FOIL. So I get 2x squared minus 3x plus 4x minus 6. Now, these two middle terms usually combine. So now I got 2x squared plus x minus 6. That's the trinomial I get when I multiply these two first binomials. Now I got to multiply all of that by 3x minus 6. Now it gets harder. And in fact, now FOIL doesn't even work. And that's why they don't teach FOIL anymore, is because it doesn't work good if you have a trinomial by a binomial. It works great for a binomial times a binomial, but it doesn't work worth anything for a trinomial by a binomial. But what does work is every term by every term. That's what you always want to do. That is the same as FOIL, and it works for trinomials, binomials, 4 terms by 4 terms. In other words, I want to do every term by every term. I want to do that, I want to do that. I want to be systematic about it. I want to do that. I want to do that. Then I want to do that. Then I want to do that. I want to add them all together.
Yeah.
Okay? Let's do that.
Okay.
What's that equal to? Tell me each term. Term by term.
Alright, we have 2x squared.
Multiply that by that. That's the first term.
3x. We have
What is 2x squared times 3x?
6x cubed.
Okay, that's our first term. What's our
Alright.
next term? That times that.
That's minus 12x squared.
What's my next term?
Do we do x times 3x?
Yep. Be methodical. In other words, always use the same method. Don't jump around. Don't do this as your next term. That's not being methodical. Methodical is satisfying this one, then satisfying the middle term, and then satisfying the third term.
Yeah.
Always go in the same order. Don't mix it up. So what's the next term?
3x squared.
Plus or minus. I need a sign on it. If I write 3x squared, it has no meaning.
Plus 3x squared.
I need the plus sign because I'm writing a polynomial. I'm not writing individual terms. I'm writing a polynomial. If it's plus, I cannot ignore it. What's the next term?
Minus 6x.
Okay. What's the next term?
Minus 12x.
What's that?
Minus 12x.
That's not minus 12.
Oh, 18x.
It's minus 18x.
Yeah.
And what's the last term?
Plus 36.
Okay. Now we just have to combine all of these. Well, when you're combining all of these, you always only have one of those and you only have one of those. So what you have to do is combine all the inside terms. So I know that my answer is 6x cubed plus 36 out here, but I can combine those two terms. What does that become?
That becomes combining the first.
What? Hold on. I got minus 12x squared plus 3x squared. What's that become? In other words, I'm combining like terms, Nick.
Yeah, that's 9x squared.
It's minus 9x squared.
Yeah.
Okay. Now combine those two terms, which are like terms.
Hold up, let me move this thing out of the way.
Okay.
6 minus 6x is minus 24x.
Good. And there's your answer. In other words, now I have just 6x cubed minus 9x squared minus 24x plus 36. I don't have anything more I can combine. And that's the volume of my figure. Again, it's going to be a function of x. They didn't give us numbers, they gave us variables. So my answer has to be a variable. And since I know I'm going to multiply an x times an x times an x, I'm going to have at least a cubic as an answer.
Yeah.
And that's what I got, was a cubic.
Alright.
Alright, hold on, let me scroll down a little bit and bring up the next page. Midpoints. Before we do 27, tell me the midpoint between these 2 points.
For what are you doing, 27?
No? Tell me the midpoint between the 2 points that I've listed there.
Is it
What's the midpoint between 2, 4 and 10, 14? And let me just draw a picture of it. Here's 2, 4. Here's 10, 14. When I say what's the midpoint, I mean what is that point right there?
2, 4.
What's the midpoint between 2 and 10?
Is that 6?
Uh-huh. What's the midpoint between 4 and 14?
Is that 8?
No? You get the midpoint by adding the two numbers and dividing by 2.
Oh, 9.
Okay. The reason I wanted to ask you about this is because that's what we're going to do to solve their problem, which does not have numbers, it has variables.
Yeah.
But the way I do it is by adding the two numbers, dividing by 2. 2 plus 10 is 12. Divide by 2, you get 6. 4 plus 14 is 18. Divide by 2, you get 9. So that's the way you find midpoints, is by adding the two things and dividing by 2. If B is the midpoint, I still need to draw a picture here. They're saying we have a line AC. Okay? And B is the midpoint. And they tell us that AB is 3x minus 2 and AC is 7x plus 2. Now in this case I can solve for x.
Yeah.
Why? What kind of an equation do I need to write? In other words, the only way I can solve for x is if I can write an equation. Always. That's the essence of math. Is you want to solve a geometry problem, you got to write an equation with one variable only in it.
Yeah.
What can I say? I know that 3x minus 2 is half of 7x plus 2.
Yeah.
Right? Well, let's say that. 3x minus 2 is 1/2 of the quantity 7x plus 2. That has to be a true statement, right?
Yeah.
In other words, if B truly is the midpoint, well then that distance is half of this distance.
Yeah.
And that's what I'm saying when I say 3x minus 2 equals half of 7x plus 2. Now we have an equation we can solve. What's the best first step?
Would it be 2 squared x?
Yes. What is the best first step to do that? That's always the answer. When you're solving an equation, the answer is isolate x. Yeah. Question is, how do you do it?
Add 2 to each side.
What's that?
Add 2.
No, probably not. Remember what I said, get rid of parentheses and denominators. We got a denominator here because of that fraction. Let's get rid of denominators. How do I get rid of that 2?
Wait, my mom wants to know if you owe her money. Yes, I owe her money.
Don't know. I haven't done the accounting. I will send her an invoice as soon as by tomorrow probably.
Alright, it's no rush.
Okay.
Alright. I'll just get rid of the 2 and get to divide each side by 2.
No, that 2 is a divisor already.
Yeah.
I want to multiply both sides by 2,
Yeah.
not divide. If I divide both sides by 2, that's going to turn into a 1/4. But if I multiply both sides by 2, gets rid of that 1/2.
Yeah.
Now what do I got?
What do you got? 2 parentheses 3x
Hold
minus
on. Do that distribution. In other words, let's simplify.
2.
It's 2 times 3x.
2 times, oh, do that, alright. 6x minus 4.
Okay. Equals what?
Equals, 3.5x.
Hold on. No. We didn't distribute the 1/2. And there was a good reason why I didn't distribute it. Because it turns that into a fraction. I don't want fractions. I multiplied both sides by 2, so that would go away. So the right side is just 7x plus 2.
Yeah.
Now, it's critical that you see why that's the perfect first step. In other words, I take a fairly complicated looking fraction, which is 3x minus 2 equals 1/2 times 7x plus 2, and I turn it into a really easy problem. And it's all I had to do was multiply both sides by 2. Now I can move the 6x over to the right. I can move the 2 over to the left. Bingo. That's what x is equal to.
Yeah.
Minus 6. Now, that's a little problematic.
Alright.
Maybe not. You see why it's problematic? It gives me a length for AB of minus 18. You can't have lengths that are minus numbers.
Yeah.
AC ends up being also a minus number.
Okay.
I guess that is not necessarily bad. Wow. I'm surprised they would do that to you. That's the only solution we get. So x equal minus 6 has to kind of be right. It has to do with how they're measuring this line. In other words, if I got a point there and I got a point there, and they're saying that distance is a negative number, minus 6, or in this case, minus 8, that's minus 8. It would only be minus 8 if I was measuring it from there in that direction. So it's conceivable that minus 8 would be an answer for that segment of the line. And AC would be minus 6 times 742, so AC would be 40. We've screwed up. Minus 8 is not half of minus 40. And it needs to be. It needs to be a midpoint. So the distance from here to there has to be exactly half of the distance from there to there. So, by virtue of the fact that our solution doesn't appear to work, let's go figure out where we made our mistake. Must have written down something wrong. That's the only thing that makes sense. Okay, AB and AC. B is the midpoint, so AB is the line segment that makes up the first half. And that's equal to half of the total line segment.
Yeah.
Now, if I multiply both sides by 2, I get 6x minus 4 equals 7x plus 2. I still get x equals minus 6.
Yeah.
Oh, that actually does work. If I plug in minus 6 for x, then AB ends up being minus 20, and AC ends up being minus 40. So it is half. So x equals minus 6 is correct. When I checked it before, I didn't do the math right. The fact that it's a negative number, I hate that they did that to you, but we'll let it slide.
Yeah.
I don't think they intentionally did that. Usually when you're working with geometry problems, you do not have any negative dimensions. You can't have a negative dimension. If I say, what are the dimensions of that parallelogram, they're all positive. There's no such thing as a negative 6 dimension. Okay, so I'm a little bit puzzled that they're coming up with the length of the line AB is minus 20. And the length of the line AC is minus 40. But I don't know whether they made a typo or they intentionally did it or what. So there's not really much I can do other than just kind of let it slide. I think it was probably accidental on their part.
Probably.
Yeah. Hold on here, sorry. Trying to find the page that I want. It's the second part of that. There we go. All right. We got 3 minutes. Hold on. What happened? Wow. Oh, we didn't answer any of these questions. Oh, we jumped around. Yeah.
Yeah, I finished it on that.
Yeah, no, that's fine. That's fine. So where'd we leave off? Gosh. 28. This is actually going to be a pretty easy problem. When you see a problem that's 2 parallel lines and a transversal, the one thing you know right off the get-go is there's only 2 angles. Everything is either angle 1 or angle 2.
Yeah.
3, 4, 5, 6, 7, and 8 are either angle 1 or angle 2.
Yeah. Angle 1 and angle 2.
That's what you have when you have parallel lines and a transversal, is you create 8 angles, but there's only 2 separate angles. In other words, angle 1 is the same as 5. It's also the same as 4. It's also the same as 8. Angle 2 is the same as 3, same as 6, same as 7. So that's what I mean by that.
All right.
Now, let's see if we can answer their problems. If m is less than 5 equals 135, what the heck does this mean? Never seen an expression like that.
I guess it means angle 5.
Ah, they mean if the measurement of 5 is equal to 135.
Yeah.
And they had to write it like this. So they meant if the measurement of angle 5 equals 135, find the measurement of angle 4. So that's 135 is 5. What's 4?
4 is also 135.
Yep. Name these angles. The measurement of angle 2 is 60. Well, not if 4 is 135, but I guess it must be a separate problem. In other words, you realize that if the measurement of angle 4 is 135, then 2 cannot be 60. In other words, these 2 angles are a linear pair. They have to be supplementary. They have to add to 180.
Yeah.
So this must be a separate problem completely. So they're saying, I imagine, that if 2 is 60, what is 7? What's angle 7?
That's also 60.
Yeah, these are pretty easy. Like I said, when you see parallel lines and a transversal, it's really easy. 1 and 2 are supplementary, and everything else is either 1 or 2. And if you have trouble figuring out which, just figure out which one's obtuse and which one's acute. In other words, 2 is acute, 1 is obtuse. So if I'm looking at any other angle, 8 is obtuse, it must be 1. 7 is acute, it must be 2. So that's what, when you have parallel lines. And this is pretty important. You're going to get 3 or 4 questions on the ACT and the SAT involving parallel lines and those angles. That's one of the most popular type questions there is when you take those college entrance exams. So make sure you know your parallel lines and transversals.
All right.
Nick, I'm going to let you go.
That sounds good.
If you need another session before your test, you let me know. I got nothing but free time.
All right,
But other than that, you're my last session. You win my honorary award for my last student of the semester. There's nothing with the award. I just always tell everybody that you're my last student. Usually, that's a pretty good thing. That means you're working your butt off. Because usually my last student of the semester is somebody that is really trying hard.
Yeah.
All right. Good luck on your test. Have a nice summer. And perhaps we'll work again together next year when you go into geometry.
All righty, sounds good.
All right, Nick. Have a good one.
Bye-bye.
Bye-bye.